We have already seen what is the TE mod and what is the TM mod and what is the TEM mod. We have seen the the full form of the TE means transverse electric mode and transverse magnetic mode. See here, there is use a suffix in a TE and TM. These are the suffix. What is means by these are suffix? M and N. This one also M and N. M and N is the integer value which is represent your TE and TM mod or wave. The field configuration means field pattern of your TEMN and TMMN means each set of integer M and N gives you different field pattern or mode referred as a TEMN and TMMN mode means transverse electric mode and transverse magnetic mode. By putting the integer value, we see the different field pattern which is propagating inside your waveguide. Now, what is meant by the integer M? Integer M represent equal number of half cycle variation in the x direction and integer N represent the equal number of half cycle variation in y direction. Means what is means by this one? Means suppose there is a rectangular waveguide, there is a cross section area you see here, means this is the dimension of width and this is your height. Now represent in the coordinates, means this is your x coordinate, consider x, this is your consider your height is considered y coordinate, means length is considered is the z coordinate. Means in the Cartesian coordinate we represent your rectangular waveguide, means this one shows M represent equal number of half cycle variation in x direction, means this one represent x direction, means half cycle variation means consider this one of the half cycle variation in x direction. Suppose consider M is equal to 1. M is equal to 1 means this is the half cycle variation. Suppose M is equal to 2, this is the again one half cycle, again next one half cycle. There is a complete cycle when M is equal to 2 means one complete cycle. Next, what is the N means? N is the number of half cycle variation in y direction, means this one your y direction, means you see the half cycle variation means this one similar form is this one your represent your half cycle variation, means suppose N consider to 1, this one represent your half cycle. Suppose consider to 2 means 2 half cycle is present in your y direction. Means overall the conclusion of M and N is the integer value which represent M represent the equal number of half cycle variation in x direction, means this one is the x direction, and N is depend the half cycle variation in the y direction. Next to move your TEMN means we put the value of your integer value different M and N value, and now see what is the field pattern is present and what is the field pattern not present, means which mod is supported or which mod is not supported. Now putting the value means M and N may be 0 and M0 and Mn. This is the supported, means we put the value 0 is the here consider 0 is the fixed value, means N is the changes, means N 1 2 3 4 whatever you put here, you see here the example is the this one, means we 0 is the constant value, 0 1 and 0 2, this one represented, means this wave is supported. And next one we have seen M is also put 1 2 3 4 whatever here, means 0 is constant, this also supported, means we put the M and N value means 1 1 2 3 4 3 whatever is, means this field pattern is inside your waveguide is supported. Means suppose we put your 0 0, then this is mod is not supported, means this field pattern is not exist in your TEMN mod. This is the meaning of your M and N, means 0 0 if we put the value of M and N is the 0 0, this is the not supported field pattern. These are the supported field pattern. And next one is the dominant mode. Dominant mode is the lowest cutoff frequency. This is your dominant mode of TEMN mode, or also 0 1. This is the dominant mode. when A is greater than B, use a TE10, and B greater than A, then this use your TE01. B move to your next MN mode. We have seen in the already value putting and see whatever your field pattern is supported and not supported. Similar way in this mode also, here you see if Mn use 00, 0 and M0, then all field components vanish. Means if in this form is present your integer value, then this field is not supported by your this field component. Means suppose the example is you see here, we put 0 0 0 1 1 0, yeah, 0 2 0, 2 3, means this field component vanish. How this component vanish? There is a equation form and put the values of M and N. In this lecture you seen the equation, just you focus only which values of integer values is present the field pattern or absent field pattern. Means neither M and nor N can be 0. Means if we want to TEMN mode, then M and N any one value is not 0. Means always present. Suppose example we take TE 1 2 2 3 4 3, means 0 1 form is not present, 1 0 form is not present, and this one one of the example your TE 1 1, means this is also got dominant mode. Means lowest cutoff frequency is called dominant mode. We move to your next, the cutoff frequency of waveguide. Also one of the derivation of the waveguide as a high pass filter. The relation is used here. This is directly written here. There is a constant here is equal to gamma square omega mu epsilon is equal to kx square plus ky square. This kx and ky's value is the value is the m pi by a, and ky is the value is the n pi by b. Now put this value and arrange in this form. This is the gamma is the propagation constant. Now gamma is equal to under root this one. You arrange this one, and gamma is also equal to alpha plus j beta. Now one of the term is also here is here. There is cutoff wave number. This is cutoff wave number relate to your kx square plus ky square. Suppose there is some numericals, find out the cutoff wave number, then we use your kc square is equal to, now put the relation. Suppose there is m value is given, a value is given now, and also n and b is value is given. You easily find your cutoff wave number. Next move your evanescent mode. Evanescent mode is the at your lower frequency. Whatever means evanescent mode is not propagating mode in your rectangular waveguide. Whatever means at lower frequency your waveguide is not supported. Means this one the relation means kx square and plus ky square must be greater than omega square mu epsilon. Now by this relation gamma is equal to alpha and beta is equal to 0. Now when gamma propagation constant is equal to attenuation constant alpha, then your wave propagator is totally attenuated. This one also evanescent mode. You see here base is completely attenuated, this no phase change. Here beta is also 0, means wave is not propagated in the evanescent mode, means at lower frequency region. When the wave is propagated, how to propagate it? Next move your at higher frequency, means propagation mode. This is also called propagation mode. By this relation, this is referring to propagation mode. In this form, gamma is equal to j beta and alpha is equal to 0, means wave is not attenuated. This referred by alpha is equal to 0. There will be phase change. Here is a beta is present. This is referring to phase change. Hence wave is propagated. Next move your cutoff. The transition gamma becomes 0 and propagation just started. Also in this page also what is means or cutoff frequency means a particular frequency which wave propagation occur, and below cutoff frequency wave is not propagating, that is called cutoff frequency. You also see here the frequency at which gamma just becomes 0 is defined as the cutoff frequency. Also one of the definition of cutoff frequency. In this gamma is equal to 0, just is gamma is equal to 0. Now put the equation in the gamma is equal to 0 and arrange in this form. Now this arrange this in form. Now we consider omega is equal to omega c, means as cutoff frequency. Now arrange this in form. Now b pi is common in this under root, then cancel out your pi and arrange again this one. This is your cutoff frequency. Now suppose in the free space mu is equal to mu naught. Mu is equal to mu naught and epsilon is equal to epsilon naught. Now put, we consider a free space. Now put mu naught and epsilon naught values. We have seen this is already explained, and next we have moved to your when we consider your free space. Mu naught and epsilon we put here. Now 1 upon mu naught epsilon naught is equal to c. You see here, we put the c here. Now pi and this one pi both are common, then cancel out this pi one. Then overall term is called c by 2. This is under root m pi by whole square plus n pi by v square. This is your cutoff frequency. The deduction of cutoff frequency. When calculate the cutoff wavelength, we know lambda is equal to c by f. By this relation, we will calculate a cutoff wavelength by putting this one and arranging this form is come out. Okay.